Dear students, welcome everyone, and today we are going to discuss some very important questions on limits, and this will be the second lecture. And thank you so much for watching the previous video. And these lectures consist of questions definitely should help you for preparation of your entrance. Okay, the first question is a very simple one. This question is basically based on the concept of the greatest integer value function. So let's start our lecture today. This is question 1. Okay, for limit x tends to 2, so greatest integer value function 2 minus x plus x minus 2 minus x. We need to evaluate this. Okay, so to evaluate this, first we'll calculate the left hand limit and right hand limit. So let us start with this. Say left hand limit. Limit x tends to, remember this, you are approaching 2 from the left hand side. Okay, the function is 2 minus x, greatest integer value function, plus x minus 2 minus x. Let us see the value of this limit. So when x will be approaches to 2, okay, from the left hand side, so the value of x will be slightly less than 2. So this value, that is the difference of these two values, since x is slightly less than 2, difference of these two values will be very close to 0, but even though that value will be positive. So greatest integer value functions of that particular value will be 0. Okay, for example, if the value 2 minus x is 0.1, then the greatest integer value function 0.1 will be equal to 0. Let's see this. So you are approaching to 2 from the left hand side, so x is slightly less than 2. So if x is slightly less than 2, so this value, that is x minus 2, will also be very small value, but this value will be negative. Okay, since this value will be negative, for example, the value could be minus 0.01. Then the greatest integer value function of minus 0.01 will be is equal to minus 1. And if we take the value on x, so it will be minus 2. So the limit comes to be minus 3. So is minus 1 minus 2 is equal to minus 3. So let us now calculate the right hand limit. Okay, this question already I said are very simple questions. So right hand limit, let's calculate right hand limit. Limit x tends to 2 plus. Remember, you are approaching 2 from the right hand side. So this is 2 minus x plus greater than the value function x minus 2 minus x. Let us calculate this value. Remember this, you are approaching 2 from the positive side, so this value, x value, is slightly greater than 2. So could be, say, x value is say 2.001. Now if you subtract this value, that is 2 minus 2.001, so it will be minus 0.001. So if you take the greatest integer value function on, that is minus 0.001, so this is equal to minus 1. Okay, now coming to this. So here x is equal to, this x is approaches to 2, so this x value is slightly greater than 2, so this difference will be very close to 0, but this value will be positive. So for example, it could be 0.001 for example. So it will be greatest integer value functions 0.001 will be equal to 0. Okay, it's equal to 0, and if you substitute the limit on x, so it's minus 2, this is equal to minus 3. So left hand limit and right hand limit both says, okay, and is equal to minus 3. Therefore this option 3 is correct. Okay, so let's move to the next question. Okay, this is also a very important question. Please observe the expressions. Limit n tend to infinity. Okay, so it's 1 by n plus e to the power 1 by n divided by n, and it goes like that, and the last term is e to the power n minus 1 by n divided by n. Okay, so we need to find the limits. First of all, we're just going to simplify these expressions. So limit n tend to infinity, so you can take at the same time you can take LCM. LCM is n. Okay, so the first term is 1 and the second term is e to the power 1 by n, and this is e to the power twice n, and it goes like that, and the last term is e to the power n minus 1 by n, done. Okay. Now this expression, the numerator, okay, just you can write in a simple way. This one can be written in terms of e to the power 1 by n. So it can be written as e to the power 1 by n to the power 0, and this e to the power n 1 by n, we can just write whole to the power 1. Okay. Now we can just write e to the power 2 by n as e to the power 1 by n whole to the power 2. So you have seen the exponent, it's 0, 1, 2, it goes like that. So last term is very important. The last term, how to write the last term? This last term we are going to write e to the power 1 by n whole to the power n minus 1. Okay, this is our very important steps. Okay, it will help you to make these questions quite easier. Okay, just if you observe this expression, e to the power 1 by n to the power 0 plus e to the power 1 by n to the power 1. So this particular series is a GP series. Okay, GP series. How many terms are there? This from 0 to n minus 1. So it has got n number of terms, and we know the sum of the GP series. Okay, just we are going to use that expressions. Okay, what is the sum? So you can just write this expression like that. Limit n tend to infinity. So this expression is, the denominator is n, and here the first term is e to the power 1 by n to the power 0. We can just take this as 1. Okay, what is the common ratio? This is 1 and this is 2, and it goes like that, and this is n minus 1. So what is the common ratio? Common ratio is e to the power 1 by n, and from 0 to n minus 1, how many terms are there? So 0 to n minus 1, n numbers of terms are there. So just we know the sum of GP, that is a r to the power n minus 1 divided by r minus 1. This is a GP sum up to nth term, that is a into r to the power n minus 1 by r minus 1. So here first term is e to the power 1 by n to the power 0. So you can just ignore the first term. So r, what is the common ratio? It's r 1 e to the power 1 by n plus e to the power 1 by n 2. So obviously the common ratio is e to the power 1 by n. So just can sum e to the power 1 by n. How many terms are there? Here n number of terms are there. Minus 1. Okay, e to the power 1 by n to the power n minus 1, and divided by e to the power 1 by n minus 1. Okay, and multiplied by n. N is already there. Okay, this is the expressions. This is the expression for the sum of the GP series from the first term to the last term. Okay, and this is n written there. Let us simplify now. What is the next step? Okay, this is e to the power 1 by n. This n will get cancelled out, so it will become e minus 1. E minus 1 is constant, so it can be written as e minus 1. It does not depend on the limit. Limit n tend to infinity. So what's left out? This is 1, and the denominator is n is there, and apart from this, e to the power 1 by n minus 1. This expression is there. Okay, now how to solve this? Okay, to solve this, to find this limit, so it is e minus 1. Just you can write this limit n tend to infinity, and this expression is 1 e to the power 1 by n minus 1. This n, what is the n in the denominator? Can be written as 1 by n. This n we can just write as 1 by n. Okay, e to the power. So the denominator expression becomes e to the power 1 by n minus 1 divided by 1 by n. And we know that limit n tend to infinity, e to the power 1 by n minus 1 by 1 by n. Okay, is equal to 1. Alright, so n tend to infinity, e to the power 1 by n minus 1 divided by 1 by n is equal to 1. So therefore, this value will be equal to 1 if you take the limit n tend to infinity. So this is equal to e minus 1 and multiplied by 1. E minus 1. So this option is correct. E minus 1 is the correct option. This is the correct option. Okay, and next. Okay, what is this next question? Next question is limit x tends to 0, sine, this is a signum function. Okay, this is signum function, that is sine signum function of x divided by signum functions, and This is greatest integer value functions. Okay, so you have to get the value of this. Okay, there are 4 options. So we'll just try to find out this limits with the help of the left hand limit and the right hand limit. Let us calculate the left hand limit first. Limit x tends to 0 minus, okay, sine if x equals to 0 minus, that means x is less than 0. We know that if x is less than 0, signum function x is equal to minus 1, right? And this is also equal to minus 1, right? Okay, limit x tends to 0 minus. Now sine minus 1 is minus sine 1, and this it will cancel with this, that is minus sine 1 and minus 1, it will get cancelled out. So that can be written as limit x tends to 0 minus sine 1. Now what is the value of this? The greatest integer value function, sine 1. So sine 1 radian. Okay, sine 1 radian is approximately sine 57 degree. Okay, so this value obviously will be lying between 0 to 1. So approximate value of this one is 0.84. Right, approximate value. Now, what is the greatest integer value function of this particular value? So this is e is equal to 0. So left hand limit is equal to 0. So right hand limit is exactly similar to this, only you should remember the signum functions. We know that for the signum functions, if x is less than 0, this signum function x is equal to minus 1. If x is greater than 0, then the value of the signum function is equal to 1. This function will give only 3 values, 0, 1 and minus 1. Okay, so let us calculate the right hand limit now. Okay, what is the right hand limit? Right hand limit, okay, x tends to 0 plus sine. So what is the value? X tends to 0 plus means x will be positive here. So sine signum function of x will be 1 and this is also 1. Okay. This is equal to limit x tends to 0 plus, that is our greatest integer value functions, that sine 1. So exactly similar explanations, that sine 1, sine 57 degree. So this value obviously will be lying between 0 to and 1. Okay, and this is equal to 0, the greatest integer value function of sine 1, that is sine 1 radian or sine approximately 57 degree. Okay, so it comes with the fractions. Okay. So the value of the greatest integer value function sine 1 is equal to 0. So hence left hand limit, right hand limit, both are equal and equal to 0. So here options, here this option is correct. This will be your correct options. Okay. So this is also another very important question. Here we are asked to the concept on this one, the greatest integer value function and signum function. Okay. Next, let us try another one very important question. Okay. This is another very important question. So limit x tends to 2. So 2 to the power x plus 2 to the power cube minus x and minus 6 divided by square root of 2 to the power minus 6 minus 2 to the power 1 minus x. So how to solve these questions? Okay. We just start in this way. X tends to 2. Okay, this is 2 to the power x. We'll just simplify these expressions. 2 to the power cube into 2 to the power minus 6. And this is minus 6, and this can be written as 2 to the power minus x by 2. This is minus 2 to the power 1 into 2 to the power minus x. Now let us see the form. What is the form? What is the indeterminate form of these expressions? If x is equal to 2, so it will be 4. This one will be 4, and this will be 2 to the power minus 2. That means 4. So 1 by 4, and if you multiply this 2 to the power cube into 2 to the power minus 2, it will be 2. So it will be 4 plus 2 is 6 minus 6. So it will be 0. And let's see the denominator. Okay, denominator. This will be 2 to the power x. So x is equal to 2. So 2 to the power minus 1 means it's half. This is equal to half. And this is 2 to the power minus 2. Okay, 2 to the power minus 2. Again, if you multiply 2 to the power minus 2 and 2 to the power 1, so this will be 2 to the power minus 1. It is also half. Look, this is also 0 by 0 form. Right? So what I am going to do is, both numerator remove, try to remove the indeterminate form. Now just try to divide both numerator and denominator by this expression, 2 to the power minus x. Okay, what is the next expressions? Limit x tends to 2. So if we divide this one by 2 to the power minus x, so this will be 2 to the power twice x plus 2q. Because you are dividing this expression by 2 to the power minus x, so this will get cancelled out. Minus 6. And 6 you are dividing by 2 to the power minus x. So it will be 6 into 2 to the power x. Right? Okay. Next, in the denominator also, you are dividing 2 to the power minus x by 2 by 2 to the power x. That means if you divide 2 to the power minus 6 by 2 by 2 to the power minus x, so it will be 2 to the power x. So if we just calculate this, right? If you calculate this, this will be this one minus x plus twice x by 2. This gives you 2 to the power x by 2. So it comes as 2 to the power x by 2, right? And this is you are dividing this one by 2 to the power minus x, so it's minus 2. This 2 to the power minus x will get cancelled out, right? So what you have done here in this expressions, both numerator and denominator you are dividing by 2 to the power minus x, right? So what I'm going to do is we just multiply both numerator and denominator by this expression 2 to the power x by 2 plus 2. We are going to multiply both numerator and denominator by these expressions 2 to the power x by 2 plus 2. Done? So what's the next steps? Next steps is very simple. Limit x tends to 2. Right? So just multiply this. 2 to the power x by 2 into 2 to the power x by 2. This will multiply this. So 2 to the power x. This will be 2 to the power x by 2 whole square. So 2 will cancel 2 to the power x and x minus 4. So you got this expressions in the denominator. Right? And numerator. Numerator, you can just simplify it one step, this numerator. So you can just write the numerator like that. 2 to the power x 2 minus 6 2 to the power x, 6 into 2 to the power x, and plus 8 and 2 to the power x by 2 plus 2. Yeah. Right. This is a numerator. So we'll just simplify the numerator now. Okay. I'll just suggest you that if you are solving along with me, and it will definitely help you a lot. Like you don't need to, you can just pause the video for a minute and you can just keep solving and you can compare the answers. Okay. What are the next steps? Limit x tends to 2. Okay. This denominator is 2 to the power x minus 4. We'll try to factorize these expressions like 2 to the power x 2 minus 6 into 2 to the power x plus 8. So can you write this expression like that? 2 to the power x 2, and this 6 to the power x can be written as 4 into 2 to the power x minus 2 into 2 to the power x. You can just write this. Minus 6 to the power x can be written as minus 4 minus 2. Why minus 4 minus 2? Because here it's 8 and coefficient of 2 to the power twice x is 1. So the product of this 8 and 2 to the power twice x is 8. So 8 can be split like 4 into 2. 4 into 2 to the power x minus 2 into 2 to the power x and plus 8. Right? So only you need to keep writing these expressions. Okay, this expression you need to only keep writing. Done. Now what's the next steps? Limit x tends to 2. Okay, this is 2 to the power x minus 4. And this can be easily factorized. From this expression you can take like 2 to the power x common. So there will be 2 to the power x minus 4. And from this expression you can take both common. You can take minus 2 common. So 2 to the power x minus 4. Done. Most important that you are taking a common term 2 to the power x minus 4. And this is multiplied by 2 to the power x by 2 plus 2. Done. So I'm just going to write the next steps. Okay. I hope like you got the idea how to solve this sum now. Okay, 2 to the power x minus 4, and this can be expressed as the product of two terms, 2 to the power x minus 2 and 2 to the power x minus 4. Okay, 2 to the power x minus 2, 2 to the power x minus 4, and this is 2 to the power x by 2 plus 2. So you can just cancel these expressions. The moment you can cancel these expressions, that 0 by 0 form is removed. Now let us try to substitute this value. Okay, if you substitute it 2 to the power x minus, no, like I've just cancelled the wrong term. This is 2 to the power x minus 4. It can be cancelled out with this expression. This will be 2 to the power x minus 2. So, okay, this will be 2 to the power x minus 2. So it got cancelled out. Okay. So 0 by 0 form is removed now. So what is left out? This is 2 to the power x minus 2. If you substitute this 2 to the power 2, that means 4 minus 2 is 2. Okay. If you substitute here 2, right? If you substitute 2, so it's 2 by 2. This will be 2 to the power 1, which is 2 plus 2, that is 4 is equal to 8. 4 into 2 is equal to 8. So your option 3 is correct. This is another very important question. Okay, let's move ahead for the next questions. Okay, this is question 5. That is limit x tends to 1. See the expressions carefully, right? See these expressions carefully. Limit x tends to 1. This is 1 minus x squared up to 1 minus x to the power twice n. And this is 1 minus x squared up to 1 minus x to the power n whole square equal to, what is the 4 options, twice in p and twice in c and twice in factorial and none of this. Okay, and if you observe these expressions, right, carefully, how many terms are there in a numerator? From 1 minus x to 1 minus x to the power twice n. Here twice n terms are there, right? Here how many terms are there? From 1 minus x to 1 minus x to the power n. Here n terms is there, n terms, and but square is there. So here also twice n terms are there. So number of terms in both the numerator and denominators are exactly same, right? Okay. Now we'll just start the sum like that. Limit x tends to 1. Okay. This is 1 minus x, right? 1 minus x squared. We're just going to do one thing. Like we're going to divide each of the term by 1 minus x. Like here, 1 minus x squared we have divided by 1 minus x, and first term also we have divided by 1 minus x. So this will be 1. So second term or first term onwards will be dividing each and every term by 1 minus x. So and the third term is 1 minus x cubed by 1 minus x. We'll keep dividing like that, and 1 minus x to the power twice n will be dividing by 1 minus x. Done? Okay. So similarly, so how many terms you are using? 1 minus x. Twice n 1 minus x you are using in a numerator. That means each and every term you are dividing by 1 minus x. We are going to do the same thing for the denominator. So just first term will be dividing by 1 minus x, right? And similarly, 1 minus x squared also you are dividing by 1 minus x. And this sequence will follow. And what is the last term? 1 minus x to the power n. Also you are dividing 1 by x. And but here square is there, right? Here square is there. So that means you are dividing the numerator and twice the number of terms you are dividing by 1 minus x. Then how many 1 minus x you are using? Twice and 1 minus x you are using. And similarly, here from the first term to nth term, you are dividing by 1 minus x. Since here square is there, so that means you are using the equal number of terms, 1 minus x, in the numerator as well as in the denominator. Okay, this first term will get cancelled out. Let's see from the second term onwards. Okay, that is 1 minus x squared, 1 minus x, 1 minus x cubed, 1 minus x. For that, we are going to use important theorem. That is limit x tends to a, x to the power n minus a to the power n divided by x minus a. We're just going to use this theorem. This is equal to n a n minus 1. We know this important theorem, n a n minus 1. So if we use the theorem, so for this second expression, the first expressions give us 1. Now what is the value of the second expressions? So here 1 minus x squared, right? Here the exponent is 2. This is 2, right? And here a is what? 1. So 1 to the power 2 minus 1 will be naturally it will be 1. So it is 2. Now for the if we use this theorem for this expression, so this will be 3. And since this value is 1, so 1 to the power 3 minus 1, like a to the power n minus 1. A to the power n minus, since a is equal, for each and every term a is equal to 1, so this a to the power n minus 1, this expression always will be 1. So we need to only write the exponent, that is 1, 2, 3, it will go on, and the last term will be twice n. Similarly, the same theorem will be using for the denominator, so this will be 1. and this will be 2, and it will go on, and this will be n, and here square is there, right? It's almost done. So 1, 2 twice n multiplications gives us what? This is twice n factorial, this is twice n factorial, and 1 to n, this is n factorial, and since square is there, n factorial into n factorial, or n factorial square. So this is equal to twice n, this is equal to what? Which expression? Twice n c n. So twice n c n is twice n factorial divided by n factorial into n factorial. So this will be the option 2. Okay, next. This will be question number 6. Okay, before we start these questions, let's see this. Okay, expression. This is limit x tends to infinity. 2 plus twice x plus sine twice x divided by twice x plus sine twice x into e to the power sine x. So how to solve these questions? So before I solve these questions, you should know that if limit x tends to infinity, what is the value of this expression? Limit x tends to infinity sine x by x. What is the value of these expressions? This always will tend to 0. Remember this. For limit x tends to infinity sine x by x, this limit always will be tending to 0. Okay, so let's start this solutions. Limit n x tends to infinity. Limit x tends to infinity. So what I'm going to do is both numerator and denominator will be dividing by x. So it will be 2 by x, and this expression will be 2, and this expression will be sine twice x by 2. Done? What are we doing? That we are dividing both numerator and denominator by x. And if we divide this with twice x by x, it will be only 2. And we are dividing this one by x, sine twice x by 2. Okay, done. And this is e to the power sine x. Let's see this now. Now for x approaches to infinity, let's see this. So 2 by infinity, this term will be will be equal to 0. This will be plus 2, and this is of course x, not 2. This is x. So for x approaches to infinity, this will approaches to 0. So if we take the limit now, so 2 by infinity, this will be 0. This will be 2, and this will approaches to 0. This will be 2, and this will be 0. And most important is this. For n tend to infinity, okay, and what is the value of e to the power sine x? For n tend to infinity, right? For only I know this question is given basically for these expressions. Otherwise, this a very simple questions. Limit n tend to infinity. What is the value of this expressions? Okay. Before that, let's see that for n tend to infinity, what is sine x? For n tend to infinity, for limit n tend to infinity, this sine x will not tend to a fixed limit. This value, limit n tend to infinity, sine x will fluctuate between -1 to 1. This value will fluctuate between -1 to 1. And since our values lies between -1 to 1, therefore for limit n tend to infinity, e to the power sine x value also lies between e and 1 by e. So this value, e to the power sine x value, fluctuates between e and 1 by e. That our value between e and 1 by e. And only because of this, since this value is not, this limit is not fixed, fluctuate between e and 1 by e, therefore the limit of this particular expression, limit of this function does not exist. So this will be the option for these questions.